one, so it is. Yeah. There you go. So we're live.
We're live here, but are we live here?
Yeah, we should be. Just refresh it. There's always some delay. Yep, we're live. There's always some delay. Yep, we're live. It is. We're live. Okay. Anyway, we're back. We're live.
Are you hearing it over there?
No, I muted it so I couldn't hear it.
I can hear it here. Oh, this is.
I turned it down. That's muted too.
This is muted too.
I turned it down. That's muted. Okay, now turn it back down because I'll hear us on there. Yes.
That's fine.
Yeah. Just so. Just hit mute on there and then we'll start going. Okay, that works. Yeah.
All right,
we're live. Hi guys. Ooh, nice. There's a shoe under there. That might be why. That's fine. It's better now. We're live. We're back for episode 3 of Past the Porin. Yeah. Same people. Colton, Michael, and Nori. Yep. Sorry, Mike's so bad. We had some technical issues, but that's okay.
Well, it's because we're getting crappy tech.
That's true. From the school. I probably shouldn't blame my school on podcast. So
we should not.
Sorry.
You can blame the school. It's possible.
It wasn't your fault that somebody. Never mind. Anyway,
well, no, it wasn't their fault, but they didn't. It's the students. They didn't talk about. Yeah. This is the students.
We're going to talk about ketone bodies and lipids. Phospholipid metabolism. Yeah.
Phospholipid metabolism.
Not just phospholipid. Yeah. Lipids in general. Yeah. Everyone's going through that. 480 students and health science students right now, so it'll be interesting to know what people know about this stuff. It's interesting stuff, honestly. It's the crux of a lot of studies I read actually earlier.
Oh yeah?
No, there's a lot of health studies about it, looking for different things that could help, like aging, your actual health, metabolism, all that stuff. It's obviously not that bad for you, but it only happens in states of starvation, obviously, things like that.
With
Ketone production. Also, neonatal periods and pregnancy, there's a high amount of ketone production. I didn't either until I looked it up earlier and realized that. That's interesting. Shows they might have more benefits than just helping you not starve to death when you don't eat all day and drink a glass of water.
True.
And then wonder why you're so unfocused.
Mm-hmm.
That's why. Not you specifically, sorry.
Oh.
Yeah. So you know.
Well, probably is.
It is. I was just trying to be nice. But that's okay.
Do I hear what AI has to say?
Oh, sure. What does AI have to say? This is why you don't use AI.
The brain's ultimate backup fuel cannot use fatty acids for energy. They're too large to cross blood-brain barrier.
Makes sense.
That's true.
Brain turns it into ketone bodies when glucose is depleted.
Mm-hmm.
It applies up to 60% of total energy requirement. So it needs sugar. The brain needs sugar. It can't use ketone.
Yep.
Any idea why they can't pass the blood-brain barrier?
They're too big.
Yeah.
They're literally too big
to pass through the vein.
There's how many different types of diffusion?
The membrane. You can't pass through the membrane because the cells are too heavily packed.
Isn't there passive diffusion? There's facilitated transport. There's active diffusion. There's a bunch of different ways they can get through a membrane, but they're just too big to do that. That's what I was saying.
Yeah. The blood brain is more passive.
Yep. Oh, okay. Go ahead. There's some right there if you want one of those nice paper towels. As you can tell, Michael's having an allergic reaction to life right now. He's just too happy to be here, but that's okay. Yeah. But anyway, yeah, no. They can't cross the blood-brain barrier, as Colton said, and I said, and Michael said. Anyway, you want to add to this conversation, sir?
Well, probably should start with looking from the beginning.
Yeah, go ahead. You start.
I start.
I'll follow up, yeah.
Okay. Well, when you eat fat, your mouth doesn't break them down at all.
What kind of fats, though? All fats?
Nope. Well, the triacylglycerides or tags.
Yep.
The big ones. And usually just like the longer chain ones.
Do you remember how long those were typically? The tags?
The tags. Typically.
Yeah.
Over
15.
It was over 16 carbons,
16?
yeah. Something around there.
What's your degree of unsaturation?
What?
What degree of unsaturation? Like how many per triacylglyceride?
It depends on the fatty acids.
Yeah, it depends on how long it is. I'm pretty sure, right? Yeah. Anyway, what were you saying?
So for the longer and the triglycerides, those aren't broken down in the mouth at all. They accumulate together, and that's called like a fat bubble, or
Yeah.
I forget, or a lipid droplet or something.
Mhm.
And those they go down to your intestines,
Yep.
where they are not. I forget there's no lipase in your intestines there.
No, I don't believe there is. Yeah.
So yeah, not in the stomach. Nothing really happens except for maybe the shorter chain fatty acids, and then the like monoinsoglycerides might be able to pass through the stomach. But then once that fat droplet gets into your duodenum, which is right below where the stomach connects to the small intestine.
Yep.
It signals the release of secretin and CCK and forget. I think there was another hormone that was released from the pancreas for those, but it signals the release of bile and pancreatic juice, which all serves to and it has a lipase in it that can help break down the triglycerides.
Yep.
And as well as emulsify it, so it breaks down the droplet into smaller, tinier droplets that can eventually pass through the intestine membrane into the bloodstream, where the shorter chain fatty acids and the monoinsoglycerides or whatever, they will be picked up by the serum albumin and then transported to the cells.
Yep.
Where they're
Uptook. That's the word you're uptaken, yes.
And then the larger ones are taken to the liver, where they are processed into lipoprotein complexes.
Lipoprotein A and lipoprotein B.
Yes. Well, like more like LDLs.
Oh yeah, VDLs, VLDLs. I was going to ask you about those.
Yeah.
Yep.
And then from there, they're shot back into the bloodstream and
chewed on.
Yep. Slowly. It's very slow.
Yeah.
Because of the cells, they have lipoprotein lipases. I'm pretty sure what they're called.
Pretty sure that's where fatty liver comes from. It takes so long to chew them up, you start gaining fat in your body, right?
Yeah, you're
eating fats is so hard to burn them off for that reason, because they get processed so slowly.
I'm not sure. That might be. I think they're different, or maybe that's the main reason.
Maybe I'm thinking of ethanol. It might be ethanol. Because when you drink a lot, you get fatty liver for that reason. It takes so long to process. Oh, they can hear us. Don't worry. Anyway, you continue this. I'll take him upstairs real quick. Come on, come on.
Oh, you can leave him around here.
No.
Why not?
Huh? He's bothering Michael.
Is he bothering you, Michael?
Yeah.
I'm not sure.
Come on.
It could be. It might not be. Allergies are funny. Probably do. I was just looking at dogs or something.
Just pet tender.
Trying to look up the biochemistry of allergies.
Yeah, we talked about something else for a little bit, but the allergies, your body recognizes it as an invader.
Yes.
That's why it releases histamine.
Histamine.
Yeah. Which I think are meant. Oh, they signal like inflammation and the coughing and all that stuff. Anaphylactic shock, I think, is.
Well, I know people have to give them antihistamines to stop with their natural protector.
Yeah, prevents histamines from causing that reaction. It's pretty interesting stuff.
Yeah.
The body just like shoots itself in the foot. Does that for a lot of reasons.
Huh?
There's no way. We're talking about allergies.
Oh, what about allergies?
Just
histamines.
How they work.
Oh, histamines, yeah. Fun stuff.
Pretty easy.
Did you finish your overview of?
I was waiting to take it back. But so yeah, once the outer, all your cells on the outside have the lipases that slowly break down the like LDLs and VLDLs and stuff in your bloodstream, and then bring the like diacylglycerides, monoacylglycerides, which are just tax or triacylglycerides.
Yep.
That have been, broken apart into the fatty acids and glycerol for single fatty acid chain. And so those are brought in and then processed from there. You guys remember anything about once they're taken into the cells?
Which part are we talking about now?
What?
When they're in the VLDLs and
Once they are brought in the cells after they were
when they're brought in the cells, they send them around to get chewed on until they're gone by the rest of the parts of the cell. They're just eating them basically for energy.
Yeah.
Yeah, that's the whole point of ketone bodies. It's just a much slower process than glycolysis, obviously, with glucose, because it takes longer to chew through them.
I mean, I guess that's true. It is longer.
I always thought glycolysis is a fast burn, and then the rest, ketone bodies, is a slow burn. That's why when you're starving, you have to survive for longer, which is why it probably takes so long to chew them down.
Oh.
You get more energy over time, but you're also still not getting the immediate energy you need, like you do with glucose when you eat food. When you eat a meal, you just like energized.
Well, the ketone bodies, they're broken down really pretty quickly into.
To what?
Okay.
That's what I'm saying. Like, what do you mean?
I don't know. I just forgot it. They're broken down into the first.
The first what?
Pyruvate. Right?
I don't think they all get broken down to pyruvate. I think some do. No, they all do. I'm thinking something completely different. I'm pretty sure. But no, they do get broken down to pyruvate, but it's not as fast as glycolysis. I know that. That's why even in starvation you get energy, but you're not as energized as if you actually ate a meal and you're like, like Max rock climbing or something. Once you eat, you're immediately energized almost. When you're starving, it feels like you're starving, but you're somehow surviving because you're slowly gathering energy from ketone bodies.
Oh, well, the feeling like starving is due to hormones. And
yes,
your body realizes that you haven't got glucose in your bloodstream.
Yeah.
So, but you still get.
You get, I think, more energy, honestly. Is it more from ketone bodies? I think it's more than glycolysis.
No, it's way less.
I thought it was a really good source of energy, is what they were saying.
It's not as good as glucose.
Why is that, though? Is it because of how slowly you get the energy, or is it because it's not like an instant shot to your blood of energy? That'd be my question.
When we learned that it was ketone bodies were pretty good.
That's what I was thinking. I thought they were better technically, is what.
The problem is that once you break down the ketone bodies into like the keto acids.
Yep.
Builds up acidic or acid and gives you ketoacidosis, which is not good.
Nope, that's not good.
Your body works at a specific pH, and if you lower it or higher,
we only get about 23.
22.5. Okay. What about from glycolysis? How many do you
get? I remember it was like 36.
Oh, sure. Maybe ketone bodies are faster though, and I was wrong the whole time.
No, the whole cycle, glycolysis.
Oh, but you shouldn't add the whole cycle, because if you're comparing glucose specifically to ketone bodies themselves give you 22.5.
Yeah, they go straight to the
versus one glucose being transformed
through all the cycles to get to that many. Yeah, so that means ketone bodies are more energy efficient, but the side effect, like you said, was the ketoacidosis issue, which arises from them. That makes sense.
So
interesting. We haven't adapted to fix that yet.
Glycolysis is the full breakdown of glycolysis is technically 38 ATP.
Yeah, that's all the way through glycolysis, citric acid cycle, ETC. Yeah, all of it. Yes, that makes more sense.
Yep. You guys remember why we make ketones?
Yeah, they're the byproduct.
Yep.
Well, like when we haven't eaten for a while.
Why we start doing it?
Yeah. Usually stored in the body.
Yeah. You're starving, you have to have a backup source of energy.
Exactly. Yeah.
That's the whole point of ketones in general.
Mm-hmm. It isn't when we're starving.
Yep.
Because they're just there.
Well,
they're just around.
Well, yes, but also because like you don't have any other source of energy, so at that point your body's in like panic mode.
Yeah.
So you gotta do something.
You can't make any more glucose and gluconeogenesis. So So
Yep.
you start breaking down the fat that you have stored.
That means if you ever want to lose weight, just starve yourself. I'm kidding. Don't do that. That's a terrible idea. Don't do that.
There's a reason you don't do that.
Don't do that. It's not a good idea at all. That's a terrible idea.
Yeah.
Anyway, now that we got through the basis of what exactly that was, we should talk about the article.
Yeah.
Interesting article, actually, about ketone body metabolism. I was interested in that part earlier when I read it, ketones and heart failure.
Oh, that one. Do you want us to put the study in the or in the chat?
Sure. Actually, you can post it in there.
We could just wait and put it in the description, like Spotify or something.
I do that anyway.
Oh, okay.
Yeah. But if anyone's watching and wants to read it, they could read it.
That's true.
So follow along, right? That's my fault. I was supposed to put it in the discussion section of the YouTube.
Can I use your YouTube channel to put it in?
Yeah, go ahead. It's literally, that's fine.
There you go. There it is for everybody.
Quick post. But the heart failure part was interesting to me. You want to read it, Michael?
Under normal conditions, the heart flexibly burns available fuel sources, but diabetic or pathologically remodeled hearts, either due to hypertension or myocardial infarction, become metabolically inflexible and abnormal structurally and hemodynamically. Hearts normally oxidize ketone bodies in preparation to their delivery. In direct competition with fatty acid and glucose utilization and myocardium as the hardest ketone body consumer per unit mass. Ketone bodies have been posed as more energetically efficient than fatty acids, yielding high more energy available for ATP synthesis per molecule of oxygen invested. However, experimental evidence has been inconsistent.
Yep.
Interesting.
That's interesting.
Sounds like a lot of research in biochemistry.
It sounds like a lot. But the fact they even found that was interesting to me.
Yeah.
I was like, oh, it's interesting.
Relationships between ketone bodies and heart failure have been recognized for decades, but interest in them has recently intensified. Circulating ketone body concentrations are increased in heart failure patients in direct proportion to cardiac filling pressures, but the mechanism and significance of these observations remains unknown. Although heart failure is associated with insulin resistance alone does not provoke ketosis. Pre-diabetic states in the absence of heart failure are actually linked to diminished ketosis.
So you have a higher chance of heart failure if you can't actually process ketone bodies as well?
That's what it seems like.
That's interesting. Which means that it is a preferred energy source of your body if you don't have
It's
glucose.
preferred for your heart, for your myocardium.
Yeah.
That's interesting.
That is interesting. What? I think it's interesting.
No, it is interesting.
Oh, why do you
Is
like
there
it?
anything you want to talk about this?
No, it was just that whole section was interesting to
The
me
whole section.
because it shows a correlation that you don't actually understand yet, but shows a correlation between
Well, if you just study a
ketosis
bit
and heart
more,
health.
if you just study more and you do some experiments, you'll figure it out.
Maybe, probably,
Probably.
hopefully.
I've never been working with this. You've never worked with
No, I've never worked with heart stuff either.
You've never worked with mammalian tissue.
Have I?
No, I haven't. Have you worked with mammalian?
I think I did in one of my biology
You're
classes.
about to.
Doing it right now.
You're doing it right now. He's just doing mammalian.
In what?
It's for my research. We're doing it's called a cytotoxicity assay.
Don't say too much. Obviously.
Well, I'm not.
I'm just saying. But...
The cytotoxicity assay is common. It's just you.
Okay.
We're gonna use bacteria and shove it into a mammalian cell and see how it kills them, or if it doesn't kill them.
Oh, okay.
Pretty interesting stuff.
I think I did do something with mammalian cells in biology. I don't remember that.
This is something for later.
Oh.
This is something that Nori had an idea about.
That was Ricky, actually.
Ricky
got
wanted
it.
to go.
Yeah.
Well, Ricky wants it to be more funny and engaging, and I don't kind of want it to be more funny and engaging.
I know. I agree. I think this is pretty fun.
This is not very fun.
It's fun. What would you say on your own podcast?
It's a biochemistry podcast.
Yeah.
Biochemistry podcast is a little bit of a...
Biochemistry not fun?
Yes.
It's not fun.
No, it is.
Okay, I thought you think it's not. Yeah. So be careful, Dr. Ben's watching.
That's true.
Is he that third viewer?
He always knows what we talked about. So, I mean, He's got to look at it somewhere. That's all I'm
Probably that.
saying.
Probably, yeah.
It's like, let's see what happened this time. Yep. But I don't know. That's interesting though. When you're going to this, you can just search for something.
No.
Well, you could. You could literally do it right now and type in the topic of today's podcast and probably find something.
What do you want to look for?
You can literally look on that site you were just on for something related to this podcast, just with the search function, and you'll probably find something.
Okay, fatty acid.
Yeah, you'll find something. I'd hope.
Probably.
New weight loss pill.
Oh, that's nice.
Yes.
Is that the site you went to?
Yeah.
Oh.
Weight loss drug called SLUPP332 is found to boost muscular and aerobic endurance in mice.
Oh. So it's like GLP, whatever that was, the Ozempic.
So here's their workout plan.
That's an ad.
I'm kidding.
That's
It's a
literally
workout plan
ad.
for mice.
That's an ad. That'd be funny.
That'd be really funny. Got fat mice, no more.
Yeah. Acts on estrogen receptor-related receptors. Estrogen receptor-related receptors. What?
Interesting.
That's a real thing? Estrogen-related receptors.
Estrogen receptor-related receptors.
So is it a receptor or not?
Where are you guys seeing? Oh, estrogen.
Estrogen receptor-related receptors. Like what? That's
ERRS. Error.
That's a terrible. Yeah.
Literally like saying error.
It's a terrible sentence. That's all I'm saying. When active, these receptors trigger metabolic changes associated with the exercise, like increased muscle ability. So the receptors trigger metabolic changes associated with exercise. Doesn't exercise already trigger changes like increased muscle ability?
Yeah.
To consume oxygen?
Yeah.
And breakdown of fat for energy? Isn't that what exercising is all about?
Yes. Yeah.
That's why this is on the site then. Because
It
it doesn't. That's the point. It doesn't make any sense. They're saying a new weight loss drug that helps you lose weight by exercising. What else helps you lose weight? Exercising. So what?
Yeah, but people don't want to exercise. They want the benefit without the input.
Right, but that pill required the input to work because you got the exercise after taking the pill and lost weight.
Yeah.
That didn't make any sense. I was so confused. Yeah. Estrogen receptor-related receptors. I'm going to say that forever now.
Which is apparently a thing.
Apparently it is a thing.
I just looked up. It looks like a receptor and it acts as a ligand itself binding to a...
So it's a receptor that doesn't know how to be a receptor for other receptors.
Yeah.
Oh, wow. Interesting. Interesting stuff.
Yeah. Well, you know, it's interesting you brought up GLP for...
you guys want to hear about
weight loss?
Ketones and tumorigenesis?
Sure.
Tumorigenesis? Cancer? Ketone bodies can cause cancer, it looks like. Or the opposite.
Really?
Well, it seems like the tumor probably uses more ketones instead
to
of
support tumor
that makes sense, actually.
expansion.
Yes,
Cancer
that would
cells
make
primarily metabolize glucose through glycogenesis. Warburg effect.
Yes, we learned
Warburg effect. You guys like Warburg effect?
Yeah.
Yeah.
Good old Mark Warburg.
No.
What? Mark Warburg, you know him?
Works.
He acts.
Yeah, everyone knows Mark Warburg.
Yeah, me too.
Also activates the pentose phosphate pathway. Lipogenesis, usually limiting mitochondrial respiration. Cancer cells deprive the glucose shift to alternative fuel sources such as acetate, glutamine, and fatty acids. Hepatic ketogenic insufficiency is associated with a more severe non-alcoholic fatty liver disease phenotype. In addition, insufficient ACAC oxidation of liver macrophages leads to steatosis. Steatosis independent but high fat diet induced hepatic fibrosis, an early stage progression toward hepatocellular carcinoma. Hepatocellular carcinoma is associated with hepatocyte loss of ketogenic capacity as BDH1 and HMG-CSH2 are decreased, while OX1 SCOT normally this doesn't mean anything.
What?
Does this mean anything to you?
Yes.
It does.
Yes. Do you not know what hepatic fibrosis is? No. You know what hepatic is? Yes.
Oh, no.
What?
Blood. And what's fibrosis?
Excess fluid.
Okay. So how does that not mean anything to you? Hepatocellular. What's that?
Hepatocellular. I don't know.
You know what hepatic is. You know what hepato is. Do you know what cellular is? I hope you do. I know you do. Yeah.
Hepa is liver, not blood.
Yeah. Oh, sorry. I thought I said hemo.
This is why it doesn't make sense.
Sorry, I wasn't paying attention.
It's liver.
No, yes, it's your liver.
So,
Hepatic cells or liver cells?
Liver
right?
cell cancers are associated with specialized
Liver
liver
cells.
cell loss of their ketogenic capacity.
Yeah, see?
Cool. So they cannot do ketosis.
Yeah. We just had to focus a bit. We knew what, you know what hepato means. You know hepato. Yes, you do. Liver. Hepato cells?
Hepatitis. That has nothing to do with liver.
It actually doesn't. I don't think. I'm pretty sure it does not have anything to do with the liver. Or I could be wrong, but. Wow! What? It's entirely about the liver.
What?
Hepatitis.
Why are you acting like you knew when we said that? You're like, oh, and now you're like, I told you.
Well, I mean, it literally has HEPA in it.
HEPA? So does HEPA have to do with liver?
Hepatic.
HEPA policy.
Oh,
We're talking about
hepatic.
HEPA policy. You said it had a HEPA in it, not a hepatic. That's what I'm saying. You said HEPA.
Okay.
HEPA, whatever.
HIPAA.
You get what I'm saying. As you can tell, even we don't know all the terminology sometimes, except for me. I just act like I don't. It's just funny seeing these guys get rage.
Sure.
But no, you know what hepatic is. That's my point. It's fine. This makes sense. Well, if any of you out there don't know what it means, I suggest Googling the term. And then once you find out that one term, it makes a whole lot more sense.
What kind of?
But by increasing global histone H3K9
Is this a amino acid replacement nomenclature right here?
No, it's a histone.
We just talked about it. It's modified histone.
Oh,
It's modified by acetylation.
Did we go over this?
H3K9 specifically,
Okay,
no.
What we talked about.
But you can read it and you can tell. It's just adding an acyl group to that histone. What histone do you think it is, though? Because it's adding it to histone, it's adding it to his own tail, right? You think it's 1, 2, 3, or 4? You should know this too, because those the most common ones that cause issues are always B. I'm pretty sure it's 1 or 3, and then there's 2, and then 4 is like the least, or maybe 4 was 1 and 4, and 3 was the least modified one, but could be any of them. But based off that, I would assume it was
probably histone 3.
Nope, it says it right there actually. Acetylation induced IL-1 beta, so it's histone 1 probably.
No.
You know so?
IL-1 beta is it's interleukin 1.
Oh, okay,
like
okay.
Released in immune response.
That makes sense.
To do inflammation and such.
You should be a doctor, Colton.
Colton should be a doctor.
You seem to know a lot about this stuff. You won't make a terrible doctor.
I will. I'm just not.
That's a terrible thing to say on a podcast. Every future med school will see. I'll be a terrible doctor. Oh.
Well, no, it's like I know where my insufficiencies in knowledge lie.
Everyone has insufficiencies in certain knowledge.
Well, that's true. I may know more OChem than you, Nori, but not as much biochem.
That's debatable, actually.
No.
You might know more biochem than me, and not as much OChem.
I think I know more than
both of us.
Both of those.
Oh,
yeah.
Sounds kind of cocky to me, and also untrue.
Sure. You can't prove that.
I can prove that.
It's unfalsifiable.
It's very falsifiable. It's very falsifiable.
Yeah. Anytime someone says, "I know more than you," or "You know more than me," anything like that, unfalsifiable. You can't.
That's true. You can't.
What are you going to relate it to?
Exactly.
How are you going to run a test?
You just take a test. Yeah. You could just take the ACS final. That's
How do you get it? Can I take it with you guys?
No, but I think you can take it for free on their site because Dr. Lamb has us take it for our final, and that's free. I'm pretty sure.
Probably.
Because I doubt the school's paying for it.
And
it does change every year, so I'm pretty sure you can just take it at the ACS website.
Yeah. Can I take the ACS final chem exam.
That's all 3 quarters though. You cannot take a. Oh, I guess so. The
Yeah.
school buys it.
Oh,
That
the
makes sense.
school has to buy it. Okay, so I wouldn't be able to do it if I wanted to.
You could ask her. She might have extra because if they sell it to the school, anyone can take it at the school. So you might be able to. I'm assuming. I doubt you buy a certain number of copies. You couldn't. You don't know how many students are in your class by the end of the quarter. Because people can drop or withdraw or whatever. So you couldn't buy like 60 the first day and have 60 in the quarter and there's only like 35 students.
That's fair.
That would make sense.
Yeah.
Cool.
Could take it. You don't want to take it.
Hmm?
I'm going to get 100% on it. So
That's funny.
69 out of 70 right here.
That's funny.
Yep, coming up.
Butyrate. You guys remember this one?
Yeah, alpha ketobutyrate. I remember that.
Butyrate.
Yep.
This one's a
Butyrate?
Butyrate.
That's
This is one of the cool ones.
molecule. Yep.
This is the one where if you have your unsaturation right here, it works better for you.
Yeah.
So snip, snip, snip. I do remember the snipping.
Yep.
That's pretty cool.
That's good.
You don't remember alpha ketobutyrate? Alpha ketobutyrate?
Glutarate.
There's a butyrate too.
There was a butyrate.
There's a butyrate, yeah.
Yeah.
There is a glutarate, but there's more than one.
How would you guys oxidize this? What's the best way to oxidize that? What would you use?
Oxidize that?
Yeah, that OH group. What molecule would you use? We use it in the lab all the time.
To oxidize?
Yep.
Are you sure we use it in the lab all the time?
Oxidizing agent. 100% every day.
What lab?
Yeah, what lab? We're not in the lab.
Biochem lab.
That we use in the lab?
Huh? It's a very clean, green oxidizing.
Talk about Malachi Green?
No.
I don't remember any green agent we used. It's green.
Hell, you use it every day for cleaning.
Detergent?
You're very close.
Yeah. We use it every day for cleaning.
Bleach.
Did you just say bleach is green?
Oh, you mean green like
Green is
Eco?
eco-friendly.
thinking bleach?
No, that doesn't make sense. You said that sounded like you were saying the color was green.
I also
I was like, no, bleach isn't green.
think bleach does oxidize.
It does, yes. It does.
And bleach
Sodium
oxidize
perchlorate.
beta.
It will. Bleach also kills originosa and all sorts of other stuff. Any bacteria really is going to die if you bleach it.
Yes, it can.
Sodium
I love how AI
hypochlorite.
just gives me good sounding garbage.
Yeah. Slop.
Flop.
AI slop. That was a very terrible way to
I
explain
should look
that
up
question.
if dragons exist.
That is fair.
Bleach is not green.
What?
Why would you look that up?
How do they know they don't exist?
Because we would have seen them by now.
I mean, they're Komodo dragon.
They don't fly and breathe fire.
I like this. I like
They
this
just
search.
ooze
It's called
poison and
Do
kill you.
unicorn exist? They're fictional.
Interesting.
Yes. So back to the article.
Wait, they use BioRender right here.
Yeah, they make
Yeah.
the picture.
Oh wow.
It's software for the public. You know, it's like professional software.
Good.
That's why Ben always has to use it and everyone else.
Mm-hmm.
Ben didn't ask you to use it. I just used
No,
it.
but he mentioned it before. He mentions sites like that all the time, I think.
I used it.
Oh, for your poster?
Yeah.
Oh, okay. I have to make some for our PowerPoint, so I was wondering where you did that. I was going to do it in like, Photoshop.
If you want to talk to Aiden about it, he has the. I can give you the credentials right now.
Oh, okay. That'll work. Well, not right now, but after the podcast, yeah. Because I need to make all the carbon sources for our presentation. Our presentation's going to be sick.
If you're just doing,
We're doing the whole year.
Well, yeah. But you could do. I found a free version of Chem Sketch.
But is it 3D though? I wanted to do them like he did, where it's 3D modeling.
Mercury. I use Mercury.
Oh, okay. Yeah. That was my idea.
I downloaded the files from PubChem.
I was gonna do ChemDraw, but we're doing a presentation, not a poster. So I want it to actually be appealing when people look at it, because it's like 10-minute presentation. That way they can look at the slides while we're speaking and actually see it.
Presentation.
Yeah.
It's crazy. He went full presentation.
Yeah. I'm doing an oral presentation final for Biochem 3, so I'm doing a presentation now so I can prepare.
What's the presentation?
Presentation, you stand in front of the judges, you talk for 10 minutes, ask you questions for 5 minutes. It's a PowerPoint presentation.
Oh.
Yep. We got 16 slides, 14 not including the intro slide and the ending slide. And then we each have 3 note cards with all our slides kind of compiled onto them. Me, Chase, and Kyle, we're going to go through all of them. It leaves us like an extra minute. And then they can we can follow up with anything else we wanted to say before they ask questions.
I didn't even know that was an option.
You guys want to
So
go?
you're not doing a poster?
We are doing a poster too. Jackie said she'll do it for us anyway. Just send her the poster. So I'm gonna do it. Yeah.
You guys want to learn about ketones, obesity, and non-alcoholic fatty liver disease?
Ketones, obesity, and non-alcoholic. Yeah, sure.
Cool.
Pretty sure you just eat too much fat, you get fatty liver. Or if you're a chronic alcoholic, you get fatty liver. Goal is go to the gym, run a lot, manage your calories.
You mean if I binge drink every 3 days, that'll give me a fatty liver?
Yes.
No.
No.
If I eat
Every 3 days?
Yeah, every 3 days.
Drinking.
First of all, no alcoholic drinks every 3 days. They drink every single day.
That's true.
Second of all, if you're not drinking every day, you're probably doing something that's healthy for you or exercising in the meantime. So it really depends on how much you're drinking every 3 days. If you're drinking like...
You said binge drinking. So like...
But what is binge drinking?
A lot.
Okay, what does that mean though? What does the term binge drinking? I don't know what that means. Honestly, don't.
Just like...
So look up.
I thought binge was
drink.
like you
binge
buy...
drink means to go farther than 3 or 4 beers.
So you're buying like packs and packs of Bud Light and just drinking all of them every couple of minutes?
Let me look up the...
Imagine it's like you're on Netflix and you binge a show, but you're doing that with alcohol.
You basically... Binge drinking is defined consistently as 0.8 or higher. 0.08 or higher.
Isn't that the legal limit?
That's the legal limit, yeah.
So how is that binge drinking if you're at the legal limit?
Because you're going more than what is considered.
But it says 0.8 or higher.
It's a pattern of alcohol consumption.
Oh, it's a pattern of constantly getting to that level.
Pattern.
Okay, okay, that makes sense. That makes more sense.
Yeah. So
He has like drinking.
So every 3 days would technically be binge drinking.
I don't really like drinking.
Really? I do. I do.
You smell it on.
Not that much. No, you don't. What?
Is it the alcohol or the weed?
What weed? I don't smoke weed.
Oh, okay. Is it the Zins?
I don't even use Zins anymore.
Oh, interesting.
No.
Really?
Yeah.
You stop?
Yep.
You just quit cold turkey.
Yeah, they're like
And now
$13 a can. I'm fine.
Well,
That's expensive. What do you
Yeah.
mean? Like, no. That's crazy.
Do you know if our friend has quit his Zin usage?
Probably not.
He probably hasn't.
No.
I think he's still popping those. Do you still see him pop those?
I don't.
Why are we talking about popping Zins?
I want to know if that causes cancer.
Yes.
No, it does not. They haven't proven it yet. Nicotine can, but the thing that actually causes it isn't nicotine. It's more like cigarettes.
What about?
And it's
Chewing
because
tobacco?
of other things in the cigarettes. Chewing tobacco does too, but that's because I think that it was pure tobacco. Versus nicotine, like with other sources that aren't like cigarettes, doesn't have as high a concentration. Also, cigarettes didn't cause cancer because of nicotine. It caused cancer because of all the other stuff they add to it. Because cigarettes aren't just nicotine. I don't know if you guys knew that.
What about
Well,
the
no,
vape
yeah,
juice?
they are good.
Vape juice, I don't think they even proved vapes cause cancer. Vapes cause other stuff like popcorn lung
Vape-
and diseases like that.
I could
But-
believe it.
Yeah, but they never
Well,
fully proved vapes cause cancer.
You're inhaling like a hot,
Yeah,
semi-hot liquid, so that
Dude, mounting
damages-
evidence indicates vaping is likely to cause cancer.
Yeah.
likely, but they haven't proven it. That's why I said.
Well,
Okay.
so let's
What?
just do it.
Well, no,
Let's
because the
go
only
through.
source of nicotine that's been proven to cause cancer were cigarettes. The rest is just, we believe it does.
Well, chewing tobacco causes mouth cancer.
That too. But I mean, like vaping and stuff, the most they found is like popcorn lung. It's never been serious.
We
Like,
get us updated to ketones.
it could. I don't know
Let's
what
go back
causes
over
it
to
exactly. I'm just saying the only verified evidence we have of that is what I just said, which is cigarettes. Wait, Flynn, come on. You're
Apparently-
soaking wet. Come on.
Apparently, nicotine could act as a tumor promoter.
That's what it is, I think, that they're saying could be the issue. But the part that's not what causes it, it promotes it. What causes it is everything else involved in the whole like thing.
Sure.
Which when you use Zins and stuff like that, not that I do anymore, but they don't have anything but just straight nicotine in them. So if there's no other factor, you're likely to not get it or skip it. For cigarettes, you're smoking all these poisons, all this stuff. Plus nicotine, you're more likely to get like, you know what I'm saying.
Sure.
Sure.
There's one word that defines all that.
What? Yeah.
The dogs went swimming. That's why they're so wet.
Oh.
Yikes. Wet dog. It's a good smell. It's probably good for your ketone body.
He actually doesn't smell that bad when he's wet. I'm surprised. Most dogs smell like.
What dog?
Yeah, they don't smell like that.
TSA cycle.
She doesn't swim. She just kind of lays down and chills.
TCA cycle. Do you like TCA cycle?
Citric acid cycle?
Is that what you mean by that?
Okay.
I forgot what it was called. That wasn't
Well,
it.
fasting TAC cycle flux is directly correlated with hepatic steatosis. Fudge!
Statosis.
Stasis.
Statosis. I'm pretty
So
sure
it
it's
is
statosis.
stasis.
Yes.
The process of being in stasis.
Statosis?
Stasis. What is statosis?
Oh, look up what steatosis is.
I think it's stay. Is it sta? You think? I think it's
Oh,
stay.
no. It's the abnormal accumulation of fat within cells.
How do you pronounce it?
Yeah.
Oh, AI.
Please AI.
Pronunciation.
Pretty sure it's statosis. Steatosis. Oh, steatosis. Okay.
Wait.
Yeah. There you go.
Steatosis.
Steatosis. Steatosis.
Thanks, Google.
Steatosis.
Steatosis. Well, I'm trying to.
Steatosis. Steatosis.
Good. Feeding behavior. Oh, here's a pretty good diagram. Okay.
Yeah, I was looking at these earlier.
Weight loss, antidepressive effect. Oh, so you go from being sad and fat to being happy. Is that how it works?
How about
Yeah, sure.
read maybe the description of this?
Oh,
So, the integrative role of ketone bodies in the nervous system. So
created with biorender. So there's a biorender page with a sad person.
interesting.
There's also the fat person and the sad person in the same side of the image there, which is interesting. I don't think all fat people are sad. I mean,
No.
It's not. Don't think it's saying that.
I think what it's saying is these are the effects of it.
Hyperphagia. That's a funny way to say
It doesn't mean you're fat. It just means you'll lose weight. It doesn't mean you're sad, but it means if you are sad, it helps you be happier. It has antidepressive effects.
Is hyperphagia
Yeah.
just a fancy
Eating.
word for saying you're a glutton?
Eating too much.
Yeah, hyperphagia means you eat too much
You're
food.
right, it is. Hyperphagia.
It doesn't mean you're a glutton though, because I think the term is meant because some
Extreme insatiable hunger.
yeah, some people really just for whatever reason get that hungry all the time, and it helps you to not feel as hungry. That's
Yeah.
what the medical term.
It's all in the brain.
Yeah, exactly.
Sure.
Yeah.
Exactly.
Yeah.
Food anticipation. You're getting excited about food.
Mhm.
It sounds bad.
I'm getting excited about Asian food here and stuff.
Yep.
You know, if you are in a survival situation and you don't eat enough food, you will be driven to eat anything. Like literally, your hormones or
Oh, this brings back memories. The Donner Party.
The Donner Party?
The Donner Party.
You ever heard of the Donner Party?
You know exactly who that is.
one is done, yes, but
Yes. And they were stuck in the cold with no food for how long? Weeks, and then suddenly started eating each other. Yeah, kind of supports your theory there.
Ill-fated group of 87 American pioneers became snowbound Sierra Nevada, died of starvation, resorted to cannibalism.
Yep, they got so hungry they started eating each other.
exactly. Yeah.
That's crazy.
It overwrites all other parts of your brain
Moral values.
Moral
to get
faculty.
to get food because you need it to survive your brain.
I'd just find a squirrel and hunt it.
Sure. Yeah. Next time we're in a survival situation like that.
Normally they
They
don't kill
I
them
will.
and eat them. It's they die and then they eat them.
Well, sometimes it,
I think sometimes they just kill them and eat them.
if they're like weak and sick, then they might put them out
I think I would just hunt something.
They're claiming that the next 5
in the
years
middle
of
of
investigation
like Arctic or up in the mountains.
I'd go find myself a nice polar bear cave and hunt some polar bears.
That's very funny.
It's not funny, it's true.
Very.
They're all over the place there.
You'll instantly die.
over in
I'd
Sierra
crack the
Nevada.
ice and go get a leopard seal and eat that.
That would instantly kill you.
No, it would not.
Why don't you say like a penguin?
I actually watched a video on a leopard seal today.
You can eat seal.
A guy went swimming, and the seal came up to him and saw its reflection in his camera, and would keep going and get penguins and bring them back and drop them in front of him, and just started getting annoyed that he wouldn't eat the penguin over and over and over
That's funny.
because it somehow saw him as like one of them, and he thinks it's because it saw its reflection in the lens of his camera, so it never associated him with being a human. It thought it was another seal.
So in a survival situation,
I would just do that and take the penguins and go eat them. Thanks for the food, bud. Yeah.
I don't think you would figure it out.
Fun finding penguins over in Sierra Nevada.
Sierra Nevada, what would I have to find them there?
Or if you
Because
were,
that's where the Donner Party was.
I thought they were in the snow.
They're in the snow, but they're nowhere near the Arctic.
So they were in Nevada?
Yeah, they were in the middle of absolutely nowhere.
Scorpions.
There are no scorpions.
In Nevada? In the desert? Yeah, there are. What lived there back then in the winter? I don't know. But it had to be before climate change, right? If it was snowing in Nevada.
right? So you're in a Nevada mountain, lives in the mountain.
Winter.
That's why I was.
What lives in the Sierra Nevada mountains? Let's look that up. There's got to be some animal that lives there. There's never no animal around you.
Probably at most like mountain goats, maybe mountain.
So you're not eating lamb?
Lions.
Like, what do you mean?
Lamb isn't goat.
Is it not?
No, that's
Oh, they're
They
different.
had to consume their pack
What are
animals.
goats then?
goat meat.
So you're not eating goats?
They were under 20 to 30 feet of snow. Had to consume their pack animals, pets, and local wildlife.
Okay, but what animals live there? Yeah, local wildlife. What animals were there?
Mice and wood rats.
There you go. Deer.
Deer.
Well, not abundant. So probably like 1 or 2 deer.
Large predators, so they'll start eating cats.
You can eat cats, coyotes, Douglas squirrel.
If you can catch, little mice and squirrels.
California grizzly bear also roam these quarries.
That would have fed them for a long time.
Good.
Okay.
Little
Not
grizzly.
see a
hunt.
picture of the Donner Party.
Yeah.
They did have guns.
Do that.
The Donner Party? Yeah, I'm pretty sure they did. Sounds like they just weren't very smart guys.
Mrs. Murphy
Okay.
said here yesterday.
Maybe.
I should get a time machine and go back in time and save them all.
The 28th page of Patrick Breen's diary recorded his observations in late, including Mrs. Murphy said here yesterday that thought she would commence on Milt and eat him. I done that. She has done so yet. It is distressing.
Well, they couldn't really write back then. But they were also freezing to death and dying, so they're probably losing brain cells like crazy.
I don't that she has done so
Mine.
yet.
Yeah. Yeah. Wikipedia is Wikipedia.
This is good stuff.
How about
They're there.
a bit more about fatty acid metabolism?
Well, we did. I tried to bring it back. See, you were interested in it.
Interested in the Donner Party?
Well, it is a great way to get into ketosis.
Yeah. That actually is, because they were definitely in
They were
ketosis. Yeah.
Ketosis.
Then they got through ketosis, and they had nothing left.
By eating people.
Well, they were, by the time that happened, there was no more ketosis to go on, apparently.
They're just ketones
Yeah.
eating ketones.
Yeah, they were completely deprived of everything at that point, I'd assume.
I mean, once you eat the people, there's still muscle.
So that's where you
But
get
I'm
the
saying to
ketones.
get to that point, like you said, where you eat anything, you probably have nothing at all left.
Because that's
Yeah.
protein degradation. That's
Yeah.
where you get your ketones.
Yeah.
Anyway, enough of cannibalism. Let's get back to the actual topic of ketosis, which does have to do with cannibalism, by the way.
So yeah, large animal human participant clinical trials should contain to supplement rodent studies that account for variation may imperfectly replicate in humans. Cool.
That is cool.
That is cool. Just remember, guys, never let your ketosis go away, or you're just going to start trying to eat people. And not a good look.
It's nasty.
That is.
I don't know if it's
Don't-
nasty. I wouldn't know that. I've never
Well,
done
no,
that.
it is nasty because you got to get over that mental hurdle, realizing I'm killing and I'm eating.
Or just eating a dead body.
I'm just eating. You guys
Yeah.
want to hear about the worst Nobel Prizes ever awarded in science? Just a full
Yeah, sure.
thing? All right. You ready? Okay. Joanna's Fibiger. Physiology or medicine? Nobel Prizes used to be awarded fairly quickly after the discovery of the event that prompted them. The instructions left by Alfred Nobel seemed to warrant the speed. However, this has occasionally led to awards for discoveries that later turned out to be bunk. Perhaps no case of this is clear cut than the 1926 Prize in Medicine, which was awarded to Fibiger's discovery of Spirophtheria carcinoma.
In
Sure,
brief,
but-
Dr. Fibiger's research appeared to show that a certain roundworm parasite could cause cancer in rats. However, later experience proved that the cancers he claimed to have observed were lesions caused by insufficient vitamin A. The roundworms he examined didn't cause cancer, although certain parasites are known to do so.
I think it was close, but no cigar.
Yeah, that wasn't that bad. That'd be way worse than that.
Oh, literature. Bob Dylan. Awarded the prize for having created new poetic expressions in the great American song tradition.
This was in 2016, by the way.
Crazy.
Okay.
Dylan's lyrics are thought to be in a different class than the poetry of Rabindranath Tagore, Pablo Neruda, or T.S. Eliot.
Okay.
Okay.
I'm a Dylan fan.
I mean-
So Bob Dylan.
Bob Dylan got a Nobel Prize.
Who's Bob Dylan?
He's a singer. You know who Bob Dylan is?
I've heard his name, but I've probably heard his song.
Yeah.
They made a movie about this guy, didn't they?
I'm pretty sure they did.
Yeah.
I mean,
Wait,
probably did.
Wait, is he still performing?
Yeah.
Born in 1941.
Oh, Mr. Tambourine Man.
You never heard Like a Rolling Stone, the song?
Maybe I have.
You most likely
I
have.
probably have.
Yes. He wrote that.
Oh, Watson and Crick. They didn't get the Nobel Prize.
No, they did get it.
They shouldn't have.
Of course they did. And they stole everything.
That is true.
Crick used to hide in people's closets and listen to their research and then go
Also,
write
a
it.
video
Like
called
what?
Rosalind Franklin couldn't deal with people.
No, because we're on stream.
Okay.
But we should end the stream now. I think it's been
Enrico
like 50.
Fermi. Oh yeah, Fermi. The Fermi paradox.
Jesus.
I'll talk about the Fermi paradox.
No. All right, guys.
All right, we better get going.
That was a fun
That was
episode.
pretty fun.
Outside of the
Nobel
whole
Prizes.
random Donner Party stuff we've been on.
Well, that was cool. No, it was important.
It was important. It did actually tie back to ketoneogenesis.
Yeah.
All right, guys.
All right.
Thanks for
See ya.
watching. We'll see you next week.
Bye.
Bye.
Oh, remember to pass the Porin.
Yeah, you should pass the porn.
Pass it.
Pass it. That's the new porn dance.